Hello everyone, good evening or good night. It is almost 11 o'clock. So, we are going to start TOC, and this is the QR code of my compiler design textbook. This is available on PW store. This will be helpful for BTech, MTech and GATE. You can buy the textbook by scanning this QR code. Okay. And this is my Telegram channel. Please join the Telegram channel. You can have discussions there with other students and also updates will be there. Okay. Now we were discussing context-free languages in the yesterday's class. We were discussing exactly about ambiguous languages. Today also we'll discuss context-free languages. Okay. Today also we'll discuss context-free languages. Hi Mohit, I am fine. So you have a YouTube channel, Mohit, called mohitcall.vocals. Do you sing songs? Do you have a YouTube channel? Okay, fine. So a language has a grammar. A language has a grammar which is ambiguous. A language has a grammar which is ambiguous. Then the language is dash. Then the language is dash. A ambiguous. B unambiguous. C no comment. D none. D none. What can you say? Very good, Mohit. If I get time, I will see your channel. Nowadays, everyone has a YouTube channel. Hello. Good. Playing guitar will help you in developing brain because you need both hands coordination. That will help your brain and also relax you. So having some hobbies is very good, right? So we cannot say that it is ambiguous or unambiguous, right? So the best option is no comment. We cannot say whether it is ambiguous or unambiguous, right? పోతా పోతా పైసలన్నీ పట్టుకపోతావారా, పెట్టుకున్నవన్నీ నువ్వు కట్టుకపోతావారా, పోరి పోరి అంటావు దాన్ని చుట్టుకుంటావారా, సక్కపోసి పెగ్గేస్తా ఆ ఆ ఆ ఆ. ठीक है. ठीक है, right? So a grammar, a language has a grammar. A language has a grammar which is unambiguous. A language has a grammar which is unambiguous. Then the language is then the language is A. Ambiguous, B. Unambiguous, C. No comment, D. None. 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 A language has a grammar which is unambiguous, then the language is. A language has a grammar which is unambiguous, then the language is. Then the language is. A language has a grammar which is unambiguous, then the language is unambiguous. Then the language is unambiguous. If a grammar G is ambiguous, if a grammar G is ambiguous and language L is, if a grammar G is ambiguous and language L is ambiguous, we can convert G into unambiguous grammar. We can convert G into unambiguous grammar. True or false? True or false? Very good. So this is false. This is false, right? If G is ambiguous, L is unambiguous. Let us say L of G. L of G is unambiguous. Then we can convert G into unambiguous grammars. Then we can convert G into unambiguous grammar. True or false? Hi Kiran, good evening. Good evening Kiran. Very good, Prashant. Very good, Prashant. Thank you, Kiran. Are you Kiran Bharadwaj? Are you Kiran Bharadwaj? Okay. So this is true. If the language is unambiguous, we can convert the ambiguous grammar into unambiguous grammar, right? Now I'll give you a grammar. Tell me whether this grammar is ambiguous. I'll give you a language. Tell me whether this language is ambiguous. A power m, b power n such that m is greater than n, union a power m, b power n such that m is less than n. Is this grammar ambiguous? Is this language ambiguous? So you are Kiran Bharadwaj, is it? Tell me about this language. Is this ambiguous grammar language or unambiguous language? Is this ambiguous language or unambiguous language? Is this language ambiguous or unambiguous? Okay, Kiran Bharadwaj, after a long time I am seeing you. How are you? Where have you been? Prashant, why is it unambiguous? Prashant, why are you saying that it is unambiguous? Why are you saying that it is unambiguous? Why are you saying that it is unambiguous? Prashant. Okay. Rule 3 not followed. Huh? Rule 3 not followed. Intersection is infinity. Intersection is 5. Okay. But you don't have to go till rule 3. You can check in rule 2 itself. Now what is rule 1? L equal to union of two languages. Okay, fine. But the second rule is both the languages collapse, right? You can write both the languages as one language. So you can write it like this. L equal to a power m, b power n such that m is not equal to n, right? m is not equal to n. Even if you go to rule number 3, it will fail. Anyway, you can catch that it is unambiguous language, right? But rule number 2 itself will fail because the language is collapsing. Because the language is collapsing, right? So this is unambiguous language. So this is unambiguous language. Unambiguous language. So this is unambiguous language. Okay. Okay. Now let's see this. A power m, b power n such that m is greater than n, union a power m, b power n such that m is less than n, union a power m, b power n such that m is equal to n. M is equal to n, right? Greater than m, greater, less and equal. Greater, less and equal. Yeah, in collapse rule, both the languages are collapsing into a single language, right? A power m, b power n such that m is not equal to n, right? Both of them are collapsing into a single language. Now answer this question. A power m, b power n such that m is less than n, m is greater than n, and m is equal to n. M is equal to n. Tell me whether this language is ambiguous or not. Answer this. Answer this question. Rule to collapse. Okay, collapse into what language? Very good. M comma n greater than or equal to 0, right? How can you write it in regular language? How can you write this in regular language, Prashant? Your answer is right. A power m, b power n such that m comma n greater than or equal to 0. How can you write it in regular language? M comma n greater than or equal to 0. How can you write it in regular language? But you can put m comma n greater than or equal to 0. M can be 0, n can be 0, right? M can be 0, n can be 0. m can be 0, n can be 0, right? So how are you going to write it in regular language? How are you going to write it in regular language? Right? So rule number 1 is language is union of 3 languages, L1 union, L2 union, L3. So rule number 1 is satisfied. Rule number 2 is it should not collapse, but here it is collapsing, right? Here it is collapsing, right? How can you write it? A power m, b power n, such that m and n can be anything, right? So this is a power m, b power n, such that m comma n greater than or equal to 0. So this one you can write it as a star, b star. This one you can write it as a star, b star, right? This one you can write it as a star, b star. So this is a single language collapsed. So this language is unambiguous. So the language is unambiguous, right? Right? Now, now you know that the languages are like this: regular, DCFL, CFL, CSL, recursive, recursively, enumerable, and all the languages, right? Now, till this part, regular and DCFL, all the languages are unambiguous. Okay, so ambiguity starts beyond DCFL. Till DCFL, the languages are unambiguous. Till DCFL, the languages are unambiguous. Okay, so what we can write is certain types of languages, certain types of languages, certain types of languages are exempted. Certain types of languages are exempted from being ambiguous, are exempted from being ambiguous. So some languages are exempted from being ambiguous, right? So such languages are regular and DCFL. So regular and DCFL languages are unambiguous. Regular and DCFL languages are unambiguous, right? And ambiguity starts beyond DCFL, right? So ambiguity starts beyond DCFL, beyond DCFL, right? Right. Now tell me about this. Is this language A star union B star? Is this ambiguous or unambiguous? A star union B star, is it ambiguous or unambiguous? Is it ambiguous or unambiguous? A star union B star. Is this ambiguous language or unambiguous language? A star union B star. Is this ambiguous language or unambiguous language? Very, very good. So, this language is regular, and I told you that regular languages are unambiguous, right? Now, if you write the grammar like this, S derives S1 or S2, S1 derives AS1 or epsilon, S2 derives BS1, BS2 or epsilon. Now, if I write the language like this, both of them are having an intersection which is epsilon. So, epsilon can be generated in two ways, right? Like this or like this. Epsilon can be generated in two ways, right? Now, what can we do is we can remove the epsilon from both of them and put it at S, right? So, we can write the grammar like this. S derives S1, S2 or epsilon. We can remove the epsilon from both of these and we can put it here. Then S1 derives AS1 or A and S2 derives BS2 or B. S2 derives BS2 or B. S1 derives AS1 or A, S2 derives BS2 or B. 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 What does this mean? There may be some ambiguous grammars for regular and DCFL, but it does not mean that the language is ambiguous. Okay. So there may be some ambiguous grammars. There may be some ambiguous grammars for regular languages and DCFL, but regular language and DCFL are unambiguous. 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 Right? If you look at regular languages, regular languages, for a language L, we can give a DFA, and this DFA can be converted to a grammar, and this grammar will be unambiguous. this grammar will be unambiguous. This grammar will be unambiguous because there is no choice. Because there is no choice. Grammar will be unambiguous because there is no choice, right? Now, coming to deterministic pushdown automata. Coming to deterministic pushdown automata. Coming to deterministic pushdown automata, a language can be deterministic pushdown automata. For a language, deterministic context-free languages. Coming to deterministic context-free language, for a language we can give deterministic pushdown automata and then convert that pushdown automata into grammar. Convert that pushdown automata into grammar, and then the grammar will be unambiguous. The grammar will be unambiguous. The grammar will be unambiguous because there is no choice. Because there is no choice. Because there is no choice. Right? Now, a grammar from a NFA may be ambiguous. Right? May or may not be ambiguous. A grammar from an NFA, a grammar from an NFA may or may not be ambiguous. May or may not be ambiguous. A grammar from an NFA may or may not be ambiguous, right? So can you give an example of a NFA which will give you ambiguous grammar and which will give you unambiguous grammar? Give me 2 NFAs in the Telegram channel. In the Telegram channel, give me 2 NFAs. One NFA should generate ambiguous grammar. Other NFA should generate unambiguous grammar. Give me examples of 2 NFAs in such a way that one NFA will generate ambiguous grammar and other NFA will generate unambiguous grammar. Answer it in Telegram channel. Answer this question in Telegram channel. Give me 2 NFAs. One NFA should generate ambiguous grammar and other NFA should generate unambiguous grammar. Okay. So I'll give you examples. Now let us say let us say there is a state S initial state, and on small a it is going to state capital A, and on small a it is going to state capital B, right? Now try to generate the grammar from this. Try to generate the grammar from this. You know how to generate right linear grammar from a finite automata. We have discussed it long back, okay? When we were discussing about regular languages, we have seen how to convert a finite automata to a right linear grammar, right? Now take this finite automata, which is an NFA, it is NFA, right? Which is NFA, and convert it into right linear grammar and see what is the grammar you are getting, ambiguous or unambiguous. And see what is the grammar you are getting, ambiguous or unambiguous. Right? So what is the grammar you are getting? S derives AA, S derives AA or AB, which means on A it is going to A and B, and both A and B are final states. Therefore, A derives epsilon, B derives epsilon, and they don't have any transitions, right? Now what is this grammar? 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 This grammar is ambiguous. How can you prove that this grammar is ambiguous? So you can write like this: S derives AA, A derives epsilon, S derives AB, B derives epsilon. So for A we are getting two trees. For small a we are getting two trees, sparse trees. Therefore the grammar is ambiguous, right? So from a NFA you may get a ambiguous grammar. If you take one more NFA, try to tell me what is the grammar generated by this, okay? What is the grammar generated by this? Try to tell me what is the grammar generated by this. Is that grammar ambiguous or unambiguous? The grammar generated by this NFA, is it ambiguous or unambiguous? Is it ambiguous or unambiguous? tell me what is the grammar generated by this. Okay, so you can say that S on A is going to A and S on A is going to B, and A is the final state. There are no transitions out of B, so we don't get any A production, right? So B does not derive anything, so B is useless. Now this is the grammar, right? Now what is this grammar? This is unambiguous grammar, right? S derives CAA epsilon. There is only one way to generate A. So if you take a NFA, the grammar we get may be ambiguous, may not be ambiguous. Okay, so remember this. I'll give you all the points here. When you convert a NFA to a grammar, it may or may not be ambiguous. It may or may not be ambiguous. It may or may not be ambiguous. If you convert a DFA to a grammar, it is always ambiguous. It is always unambiguous. It is always unambiguous. If you convert a DPDA to a grammar, it is always unambiguous. It is always unambiguous. It is always unambiguous. Right? Right? For regular languages and DCFL, there exists at least one unambiguous grammars. There exists at least one unambiguous grammars. There exists at least one unambiguous grammars. Right? Some non-DCFL languages are unambiguous. Some non-DCFL languages are unambiguous. Can you think of any example where a non-DCFL language is unambiguous? Can you think of any example where a non-DCFL language is unambiguous? Where a non-DCFL language is unambiguous? Can you think of any example? Can you think of any example where non-DCFL languages are unambiguous? So I'll give you an example, right? Now tell me about this language. A power n, b power n, union a power n, b power 2n. What language is this? Is this deterministic context-free language or non-deterministic context-free language? Is this deterministic context-free language or non-deterministic context-free language? Is this language deterministic context-free language or non-deterministic context-free language? We have seen this, right? Long back we have seen this grammar, right? So do you remember that? Is this deterministic context-free language or non-deterministic context-free language? So this language is non-deterministic context-free language, right? Non-deterministic context-free language. Because we are not able to give DPDA for this, we have given NPDA. We don't know how many A's to push, so we have given NPDA for this, right? Now, what language is this? Is this ambiguous language or unambiguous language? Is this language ambiguous language or unambiguous language? Answer this. Is this language ambiguous language or unambiguous language? It is non-deterministic context-free language, but is it ambiguous language or unambiguous language? Is it ambiguous language or unambiguous language? Very good, Prashant. It is non-deterministic context-free language. Now my question is this ambiguous language or unambiguous language? Now my question is this ambiguous language or unambiguous language? Unambiguous but not sure. So apply the three rules, right? What is rule number one? L equal to L1 union L2. Yes, L1 union L2. What is rule number two? They should not collapse. They should not collapse, right? Yes, they are not collapsing. What is rule number three? Intersection should be infinite, right? So L1 intersection L2 should be infinite. But here if you observe, L1 intersection L2 is not infinite. It is finite, that equal to epsilon, right? That equal to epsilon. So you can generate a unambiguous language grammar for this, which means non-deterministic context-free language can also be unambiguous. Can also be unambiguous. This is a classic example, right? So what is the grammar? If you directly write the grammar, you may write the grammar like this. S derives S1 or S2. S1 derives A S1B or epsilon. S2 derives A S2B, A S2BB or epsilon. A S2BB or epsilon. A S2BB or epsilon. right? So this language is ambiguous. This grammar is ambiguous. How is this grammar ambiguous? S derives S1 or epsilon, S derives S2 or epsilon, but you can remove this ambiguity. Why? Because intersection between S1 and S2 is only epsilon, right? Intersection between S1 and S2. How to get 9 plus CGPA in college? GATE preparation will help you in getting 9 plus CGPA. If you prepare GATE well, you can in all those subjects you will get 100 out of 100, and some of the subjects are related to those subjects in which you will get very good marks. Okay, preparing for GATE will definitely give you 9 CGPA. Okay, so now convert this grammar into unambiguous grammar. This grammar is ambiguous. Convert the grammar into unambiguous grammar. Right? How are you going to write an unambiguous grammar? You can remove epsilon and you can put it here. S derives S1 or S2. You can put epsilon at S and you can remove epsilon from here. A S1, B or AB. S2 derives A S2, BB or ABB. AS2BB or ABB. AS2BB or ABB. Right? Right? Now let us look at membership algorithm. Right? What is membership algorithm? Given a string W, does it belong to a language? Given a string W, does it belong to a language? Yes or no? Given a string W, does it belong to a language? Yes or no? Does it belong to a language? Yes or no? Does it belong to a language? Yes or no? So membership problem is decidable. Membership problem is decidable. Membership problem is decidable in regular DCFL, CFL, regular DCFL, CFL, CSL and recursive languages, right? So why do you think that membership is decidable in these languages? Why do you think that membership is decidable? Very good, Prashant. Why do you think that membership is decidable in these languages? Why do you think that membership is decidable in regular DCFL, CFL, CSL, and recursive? Why do you think that membership is decidable in all this? Right? Simple logic is you have to understand the machines for each one of them, and those machines actually halt, right? So for regular language, there is finite automata, and finite automata halts, which means it will say yes or no. Given a string, it will say yes or no. And for DCFL, deterministic context free languages, there is DPDA, and DPDA halts, which means it will say yes or no. DPDA halts means it will say yes or no. Now, for context free languages, there is push down automata, and push down automata halts, which means it will say yes or no. And for CSL, we have linear bounded automata, and this machine halts, right? Which means it is saying yes or no. It is saying yes or no, right? And for recursive languages, there is halting Turing machine. The name itself says that it is halting. So it halts. So it will say yes or no. Now coming to recursively enumerable languages, we have Turing machine, and the Turing machine problem is it may halt or may not halt. We will see it later, okay? It may halt or may not halt. Therefore, membership problem is undecidable here. Membership problem is undecidable. Okay, fine. We will end the class here. We will continue tomorrow. Thank you. Good morning and Jai Hind. Okay, it is already 12 o'clock. So, your day is going to start with me. Good morning. Jai Hind. Okay.